This is UIK CS1 to 55. In this video, we'll be implementing a fifth experiment, that is traveling salesman problem, as part of our design and analysis of algorithms lab. So on the right hand side, we can see a graph given, which is nothing but the input for this problem. So traveling salesman problem, we basically what we have to do is we just have to calculate the possible minimum possible cost for the traveler, I mean the salesman, so that he visits each of this vertex. So here the vertices of the graph can be assumed as a city, each city. So each vertex can be assumed as a city, and the weights on these edges can be assumed as the cost of reaching the particular vertex from uh, for example, if the traveler has to reach 2 from 1, the cost should be 10 in this case. So likewise we have to assume, and we have to calculate the total possible minimum cost, and we have to calculate the path in which the traveler has to travel, so that the cost, I mean the or the expenditure for him will be minimum. So in this video we'll be implementing this. First we'll see how to solve this. So we can assume 1 as a starting vertex here, and if the traveler is currently at this vertex in this city, then he has 3 ways, right? He can go to 2, either he can go to 2, either or he can go to 4, or he can go to 3. So the traveler has 3 choices here. So what we have to do is, staying at the same the current city 1, we just have to calculate the to and fro expenditure for each vertex. For example, for the vertex 2 or the city 2, the expenditure at the to and fro expenditure should be 15. 10 plus 5, 15, right? For 4, here we can see 20 and 8. So if the traveler has to go to 4 and come back to his starting vertex, I mean his current place, then the expenditure for him would be 28. So if the traveler has to go to 3 and come back to his place, then the expenditure would be 21. Out of this, we can see that 15 is minimum, right? So the traveler has to, I mean the traveler have to go to this city, I mean 2. So there's a constraint that each vertex has to be visited only once. So 1 is already his starting place, and if he goes to 2, then 2 will be his current city, right? So from there we have another 2 choices, 3 and 4. Since 1 is already visited, 1 is already his starting vertex, right? So we just have to mark 1 as visited. So now we have 2 choices, 3 and 4. Now we have to calculate the to and fro expenditure for these 2 cities, I mean 3 and 4. So for 3 it is 13 plus 9 would be 22, and for 4 it is 18. So obviously he will go to 4 because the expenditure for 4 is lesser. And if he comes to 4 here, then there would be only one choice for him. Since 1 and 2 are already visited, he just have to go to 3, since that is the only possible path for him. Now the expenditure for 3 is to go and come back to his 4 is 12 plus 9 would be 21. So uh, that is the only possible path, right? So he has to travel to 3. So there's a constraint that the traveler has to come back to his place. I mean his starting vertex was 1, so he has to come back to 1. So now he is at 3. Now if now in this case you just have to consider the two expenditure, I mean 6, because once the traveler has reached 1, he doesn't have to come back to 3, and since 1 is his starting vertex. So in that case we'll have to calculate the total cost of the salesman, and also the path in which he has to travel, so that the expenditure for him would be minimum. Now we will implement the same traveling salesman problem code using Java. So just now we have seen the procedure or the algorithm how to solve a traveling salesman problem. Now we'll start from the main function below. So here is the main function, and I have defined some functions in this code. The first function is happens to be inputs. Now that is nothing but taking all the inputs from the user. So these are the class variables which can be accessed by all the methods of this particular class. So this is the inputs function which I have defined. So using the scanner class, we are taking the input for number of vertices in the starting vertex, and we're actually taking input for this 2-dimensional array as well. So that is nothing but the cost matrix. So once let us go to the cost matrix here. So this is the cost matrix, so which is nothing but the distances between any of the 2 vertices. For example, distance between the vertex 1 and 2 would be 10. So again 2 and 1 would be 5, so 2 and 1 would be 5 here. So that's what the cost matrix means here. That's what I have defined as two-dimensional cost matrix. So I'm taking the input for that two-dimensional array within two nested loops, and that's it. After that I'm just printing the cost matrix here, and to do the print operation also we require two for loops for that array, right? So that's what I've done. And next we have another. So let's go back to the function called inputs. So here is the inputs. Now next we have a print statement called salesman's path, and next we have another function called that is shortest distance. So this is the shortest distance here function, and this takes one parameter, that is int c vertex. C vertex means the current vertex, I mean, or the starting vertex of the traveler. So here we are passing the current vertex to that shortest distance function. So I've already told that visited array. So visited array is nothing but we'll keep a track of that array, that vertices which have been visited, so that we don't visit those vertices more than once. So that happens to be a boolean array, and initially all the I mean initially the array would be false, and so we should assign a true to that. So that's what we are doing here. Visited array, the starting vertex, I mean the current vertex minus 1, that should be 0, right? So that in that place I'm setting that to true, so that we won't consider that vertex afterwards. So after that I'm giving print statement c vertex, I mean the one, and this arrow symbol, and after that I have another function called next visit. So next visit is a function I will define, which is used to calculate the shortest nearest I mean the nearest vertex based on the to and fro expenditure between between those vertices, and it returns the uh, next possible vertex which the traveler can uh, move to. So this is a next visit function here, and here we can see some variables in main equal to integer dot max value. So in the case of for example, if you have to find maximum of any numbers, you would set a max value to 0 initially, right? So to find a minimum value, we just have to give like this: minimum equal to integer dot max value. It means that we can assume that minimum has set got set with some infinite value. So and int cost spent. So I have already told that we have to, in the algorithm, that we have to keep a track of the cost which has been spent so far in traveling the cities. So if the traveler has traveled from 1 to 2, so the cost spent has to be the expenditure between 1 and 2. So that is initially set to 0, and next vertex equals integer dot max value. Actually next vertex happens to be one of the vertices in the given graph. It should not be integer dot max value, but initially it is set to like that. So in this nested conditions below, we'll assign some original vertex to that. So I have a loop here, this for loop which runs a number of vertices times, and under that loop I have two conditions, that is first if and second if. uh, in the first if condition we have a two-dimensional cost matrix. We are checking a condition. So that condition happens to be that it's not be a diagonal. So if both these any of the entries in the two-dimensional matrix is 0, means that that entry happens to be the of the diagonal, right? So if that is 0, it I mean that entry happens to be any diagonal, one of the diagonals. So if that is true, then we will not be considering the calculation for that diagonal entry. And also we have another condition, visited copy array of I, that if not of that is true, then we'll consider, otherwise we will not consider. That means here we can see below I have set true to that array, and if not of true would be false, right? So if you set true here, it means like that vertex is already visited, so you don't need to visit that vertex again. So that is those are the two conditions under this if. And we have another if here. This is another if. So this is where we are trying to find the minimum path, minimum expenditure. So this one is the two-dimensional cost matrix c vertex minus 1 of I. This is the two vertex, I mean expenditure to reach that particular vertex, and the expenditure, this one is the expenditure to come back to that come back to the current, I mean the previous vertex. So if that is less than minimum, it should be obviously less than the infinite value, and then we would be assigning minimum to that, uh, I mean this value to this minimum, and in that way the minimum path, I mean the shortest path for that vertex would be calculated, and that would be sent. So here we can see cost spent equals to this one. This is the to, I mean the expenditure to reach that vertex. So this is nothing but the expenditure to reach that vertex, and I'm storing that in cost spent. So here I'm already adding that cost spent to the total minimum cost variable, which is a class variable defined above. So here we can see we have a condition, again we have condition if minimum not equals to digit or max value. So if minimum, for example, here we can see minimum equal to integer dot max value. Here it has been updated to some value. So why when do you update this? So only uh, if any of the vertex is still unvisited. If all the vertices have been visited, then you won't consider these statements under if. So the conditions of the if would be false, and you would have still have minimum equal to integer dot max value. So if that is true, then will not be adding any cost to the total minimum cost variable. And after that we have return statement called return next vertex plus one. So this next vertex would be would be the city or a vertex where the traveler has to stay for, I mean go to, and we are returning that particular vertex to the function. Here is the function called, and we are returning that one to the next vertex. So if the next vertex is equals to integer dot max value plus 1, then if the next value has not been updated in the under these conditions, it means that all the vertices are visited, and we are printing the current vertex as the starting vertex, and uh, total minimum cost, I mean we are adding the cost from reaching the current vertex to the starting vertex, and we are returning from the function. If not, we are again calling the same function, total distance function, with the current location of the traveler next visit equals to, then this cycle continues until all the vertices have been visited. So once we'll run this program and check for the output. So let us go with this same input. Yes, this is the cost matrix, so we'll be entering that one and verifying our output. There are 4 cities, and starting vertex, assume it to be 1. 1 to 2 is 10, 1 to 3 is 15, 1 to 4 20, 2 to 1 is 5, and 2 to 3 is 9, 2 to 4 is 10, 3 to 1 is 6, 3 to 2 is 13, 3 to 3 is 0, and 3 to 4 is 12, and 4 to 1 is 8, 4 to 2 is also 8, and 4 to 3 is 9. So this is the cost matrix that has been entered, and this is the salesman possible path. I mean if the salesman travels in this path, the expenditure for him would be minimum. So here we can see the solution is 1 to 4 3 and 1, and the tour cost happens to be 10 plus 10 plus 9 plus 6, that is nothing but 36. I hope the output for this program is correct, and thanks for watching.